Here we have an example. It says a limit below represents the derivative of some function f of x. They basically want us to work backwards, find out what is the function, there's the answer, and what is a. How did they come up with that? Well, basically, you've got to remember that the f prime of x, which is the derivative, that little prime means derivative, is equal to the limit as h goes to 0, which they definitely have in the front there, and of what? Well, it's of f of x plus h minus f of x all over h. That's called the difference quotient, right? The subtraction fraction. So this is this. You just have to match up the pieces. So what is it? Well, f of x plus h must somehow be that. So how can f of x plus h be 5, 2 plus h to the fourth? Somehow they've taken something, some kind of function, and they've plugged in x plus h, and it came out to be this. What must the x be and the h be? Well, do you see by looking at it that this must be 2, and this must be the function f of x equals 5x to the fourth. See the general form? It's 5 something to the fourth, and the something they plugged in is the 2 plus h. The whole x plus h, or in this case 2 plus h, is plugged into something of the form with a 5 in the front and a 4 in the power, right? If you had this and then you plugged in 2 plus h for x, see what you would get? 2 plus h to the fourth. You would get, oops, I'm getting lost. You would get, this would then match this, wouldn't it? Now, what about the back part? What about the f of x? Well, again, the x is 2, right? Right here, the x is 2. So if you put 2 into this function, be 5 times 2 to the fourth. Hit the buttons on your calculator and you will see indeed it is an 80. So long story short, the f of x is 5x to the fourth. And the number, they're calling it a, call it x, call it Joe if you want. It's the number 2. 2. I just kind of scribble over the top of it. 2 right there that we're plugging in. So they're just wanting you to get used to the difference quotient by looking at it backwards. That's all this problem is about. Just trying to get you more and more comfortable with this bad boy right here, because this is really important. This is the difference quotient. It is the derivative. Whenever they say the derivative or the slope of the tangent line, it means this thing, because this is a fancy y2 minus y1 over x2 minus x1. I showed the derivation in an earlier video about how it's a big slope. It's a big y2. This is a big y1. This is x2 minus x1. How that all happens, this is the derivative. So when they give you something like this, you can work backwards, go, oh, it must have been the function. Just look at the number in the front and the power here. It's 5x to the fourth, 5x to the fourth, and they plugged in 2 plus h. So the number they're putting in with the h is the 2, because the h is already there. We know that. It's the 2. So it's just practice looking at the difference quotient backwards. I want you to see it forward and backwards and get really comfortable with it. It's a big deal to us. And there we go.